In this part of the lecture, we are focusing on the automated discovery of BPMN models, the main elements used in those models, as well as the scenarios in which you would like to discover BPMN models instead of process maps. To begin with, as we saw in the previous part of the lecture, process maps have some severe limitations. They overgeneralize, meaning that some paths of a process map might actually not exist and might not make sense. For example, if you were to draw a process map of ABC, ADC, AFCE, AFEC, and check which cases it can recognize, then you can find multiple ones where there is no support for them in the event log. For example, AFE or ADE. There are even simpler examples, such as ABCD, ACBD. And if you were to draw it out, it becomes quite clear that process maps make it very difficult to distinguish conditional branching, as well as parallelism and sometimes even loops. The solution here is to apply automated process discovery of BPMN models. Those models are going to give you extra notational elements that are going to allow you to better understand what is going on in the decision points of a process. In process mining tools that support the automated discovery of BPMN models, from the user's perspective, it's always quite simple. Usually it's just a matter of flipping a switch in the user interface to get from a process map to an actual BPMN model. This BPMN model is going to be created based on a given configuration of node and arc sliders and additionally a parallelism slider. As a result, you can see that in the original model or process map, the loop that you had, if it's actually a case of parallelism or if it is a true loop. And on the example on this slide, you can actually see that the back and forth between inform user and test repair turns out to be parallelism. But to understand how I was able to tell that in the previous example there was a case of parallelism, I have to discuss the BPMN process modeling notation. This notation is based on flowcharts. It has a core set of notation elements, and each core element has various subtypes. Some of these elements we are already familiar with, for example activities, start events, and end events. Gateways is something that we will be discussing in later slides, but this is a new element not present in the process maps. Sequence flows, however, they are pretty much the same as in process maps, although the only difference is that a sequence flow can also go from an activity to a gateway or from a gateway to another gateway. Now, the different types of gateways is the most important part of this lecture. In total, I am going to introduce 3 of them, beginning with the XOR gateway. An XOR gateway captures decision points via XOR splits and points where alternative flows are merged via XOR joins. So an XOR split takes exactly one outgoing branch, usually depending on the condition on top of that branch. Meanwhile, XOR join proceeds when one incoming branch has completed. For example, in an invoice checking process, first of all, we are going to check invoice for mismatches. After that, we reach a decision point, an XOR gateway. If we have no mismatches, then we are going to post the invoice and continue with the process flow. If there are mismatches, but those can be corrected, then we are going to resend the invoice to the customer and continue with the process flow. But if their mismatches cannot be corrected, then we are going to block the invoice and continue with the process flow. And in doing so, we are going to reach the XOR join. And given that at least one of the incoming branches has finished, we can go through the XOR join, park the invoice, and finish the process execution. The next gateway type that we are going to discuss is the AND gateway. So an AND gateway provides a mechanism to create and synchronize parallel flows. We have an AND split, which is going to take all outgoing branches, regardless of how many there are. Meanwhile, the AND join is going to proceed when all incoming branches have completed, regardless of how many there actually are. To give you an example, let's take a look at an airport security check. So at the beginning, we are going to proceed to the security check. We have to do security screening and luggage screening. So the control flow of the process is going to split into two. And here we can first do the security screening and then luggage screening. But we could also do luggage screening and then security screening, as well as doing both of those activities at the same time. Finally, once both are done, the control flow is going to merge again. We are going to proceed to the departure level and finish the process execution. The final gateway type that we are going to look at is the OR gateway. So an OR gateway provides a mechanism to create and synchronize N out of M parallel flows. An OR split is going to take one or more branches depending on the conditions. So it kinda can support parallelism as well, but it's not required. Similarly, an OR join is going to proceed when all active incoming branches have completed. To give you an example, let's take a look at an order distribution process. First of all, we are going to check order line items. Depending on the availability, we can execute one of the branches, so forward the order to Amsterdam warehouse and continue from there. We could also find out that the order contains Hamburg products, forward the order to that warehouse and continue from there. However, it is possible that both of the warehouses contain some of the parts of the orders that are required, so we can execute the process for both of them in parallel. And after that is done, we can register the order and finish the process execution. To get a better understanding of how those three gateway types are going to work on a BPMN model, let's take a look at the example on the slide here. What I have is A followed by an AND gateway, and there is a lower branch or a lower path which has just activity C. Once activity C finishes, then it reaches an unknown gateway. Then the upper path, we have B followed by an XOR gateway or an XOR split, after which you can execute either E or D. However, note here that if we execute E, then D will never be executed and that branch will never reach the currently unknown gateway. So the question becomes, what type of gateway fits there? If we were to use an XOR gateway, then that wouldn't really work, because as we remember, an XOR join is going to continue the moment one of its incoming branches finishes. Meanwhile, a parallel gateway, on the other hand, wouldn't work either, because that one is going to finish when all of its incoming branches are going to finish. And as we saw, that might not be the case always here. So the correct answer is that we need a simple OR gateway. Why? Because the OR gateway keeps track of the active branches. So after the parallel gateway in front of B and C, it kinda understands that C is going to be executed, so this is an active branch and has to finish. However, once B is executed and that execution is going to be followed by E, then that branch is no longer considered to be active, and thus the process execution can continue also with F. One additional aspect of BPMN that I have to mention is how loops in BPMN appear. So a rework loop in a discovered BPMN process model takes the form of an XOR split, where one or more arcs leads to an earlier state in the process control flow. More specifically, it's going to look like this. In the control flow, at first you're going to have an XOR join, which is going to be the entry point of the loop. And later on, you are going to have an XOR split, which is going to be the exit point of the loop. Alternatively, this XOR split, of course, is going to loop back to the earlier state in the process control flow, and thus allowing you to continue looping around until the necessary conditions have been met in order to exit that loop. And now that we have discussed the main aspects of BPMN process models, let's take a look at how those models actually look like in Apromore. So here I have the same event log and the same process map that we looked at in the previous part of the lecture. If we are going to zoom in a bit, we will remember that there was a decision point here, but more importantly or more interestingly, we remember that there was potential parallelism between those three activities. And this we decided based on the back and forth arcs, which might be short work loop, but actually it might indicate parallelism. And this is something that we can't distinguish from the process map alone. In order to take a better look at it, I am going to go to visualization settings and switch it to the BPMN model. Now the model that it gives me, given the current abstraction settings, is not much more informative than what we had before. However, if I'm going to add a bit more arcs into this process model, then I get, on the one hand, a bit more complicated model, but on the other hand, it is quite a bit more informative. So let's take a look here. We had CRP, and we were thinking that maybe it runs in parallel with lactic acid. So let's see if that is indeed possible. We have a parallel gateway here. We have this one and this potential arc. From here, we can go to CRP. However, from here, we can actually go directly to lactic acid. So there is at least the potential for executing both of those activities in parallel or at the same time. The other one that we were interested in was leukocytes. And this one is actually here. It's quite a bit far away visually, but this visual distance can be deceptive on a process map or a BPMN model. So let's see here. We have CRP, in front of it an XOR gateway. Here we have a parallel or an AND gateway. But if we go a bit further, then here we see another parallel gateway, and from it there is a long arc going here, which directly leads us to leukocytes. So actually there is a case where leukocytes can run in parallel with CRP as well. Now, of course, you could mess around with the abstraction settings more, but this is the basic idea of why you would want to use the BPMN model and how to work with it.